Okay, this video we're going to look at contouring, and this is going to be contouring all by itself, just like the hole making was hole making all by itself. And then next we'll do pocketing all by itself, just to focus on those strategies one at a time, and then we'll start putting them all together to machine an entire part with a sensible strategy. All right, so we're going to work on the sprocket here, and I'm going to create two tools. I'm just going to create a 1/2 inch roughing end mill, no corner radius. I jumped over the length here. We'll just say 2 inches long with 1 1/4 inch of flute, 3 flute, and we'll say that's solid carbide, and a 1/2 inch finishing end mill that will make a 5 flute. And we're just going to use these two tools to machine this shape out. And all we're going to do, we're not going to rough it. We're not, we're going to use this as to rough it, but it's just going to cut this shape, leaving 10 or 15 thousandths stock. We're not going to turn the entire piece of stock into chips, leaving that standing. We will do that, but not here. We're just wanting to control a contour process. So I'm going to bring my roughing end mill down and do a contour with it, not a roughing, but a contour. And speeds and feeds, I've got an entry-exit move here. I can use a line with a 90-degree radius, which is what I typically choose, and these are normal numbers that I might put in there. A 90-degree line would just be a perpendicular line to the first move. And advanced activates your entry-exit tab up here, where you can come and give it a lot more control over your entry-exit move. For general stuff, I just typically use line with a 90-degree radius with 0.1 in both those fields. Extra offsets will create a move prior to your finishing move, one or more moves prior to your finishing moves further away, and then work it back in, basically. I'm going to leave 15 thousandths stock on this because this is my roughing pass. No Z-stock, no overlap, no spring passes. Clearance coming in 100 thousandths, clearance coming out 100 thousandths, 0 for the top of the part value or the toolpath calculation depth. And we're going to go minus 1.02 to get all the way through here. Now, we need to talk about this area here a little bit. This is your Z-step control. We're going 1 inch 20 thousandths deep, and it's asking for our desired Z-step. Now, it's important to understand that the desired Z-step is actually a maximum desired Z-step. Your actual Z-step will never exceed this number. Okay, so it's set to 1 inch 20 thousandths. It just basically calculates it to take it in one pass. If I drop that even 1/10 thousandths to 1 inch 119 9/10ths, my actual drops down to 510 thousandths. Even though this is only 1/10 less than the total that it's going, it will not exceed this number. It will stay at that number until I get down to 510 thousandths, and then when I go down to 5099, we drop to 3 passes of 340 thousandths. So be aware of the way that these interact. The desired Z-step is actually the maximum Z-step. All right, so let's go minus 1.02. I reset that. I put a different number in there and typed it in again so that it would give us the one step down easily, so it looked like it looks when you first enter it. If you are like me and you think more in terms of how many steps you want to take, say I know I want to take 3 step downs, and I don't want to calculate what that would be, and I don't want to guess. I know it's going to be a little over 330 thousandths, something greater than that. I typically just click on the end of this when it first comes up and say divided by 3, and that way if I'm more concerned with an actual number here, I can enter it, but then you're going to have to play with it to get to decide whether 3 or 4 is going to be closer to the number that you're shooting for. So, that's just an option here. All right, now, anytime the number of passes is greater than 1, then these check boxes down here come into play, and actually this ramp down comes into play even if it's just 1 pass. Retracts tells the software to machine the first pass at 340 thousandths D, and then retract back to the clearance plane and wrap it to the next starting position, and then feed back down to 680 thousandths D and make the next pass, and so forth. If that is turned off, it's going to do the first pass, and when it gets to the end point of the first pass, it's going to feed in a straight line to the next starting position, and then down to the next Z level, and then machine that, so it doesn't retract out of the part. Now, the important thing to understand is this does save a little bit of time if you're starting and end points are close together, but I always leave this turned on by default and only turn it off if I deliberately want it off. And the reason is this is not an intelligent do not retract. It is a feed in a straight line no matter what's between the end point and the next start point. So if there happens to be an island in between, it's just going to plow right through the island. If there's a clamp there, it's going to plow through the clamp. So I typically leave this on until I've created the toolpath and I see where my start and end points are. I'm going to turn that off right now though, for a reason, and we'll get to that in a little bit. All right, depth first really to me is more an issue for roughing, but it also can apply to contouring. But basically, if the tool coming off the part here causes it not to create toolpath, then that's something that you can adjust. But so you would have a contour here, and then maybe another contour here. It's going to, depth first tells it to do this one until it gets all the way down, then go to the next one until it's all the way down. I think of it more in terms of pocketing, where if you've got 3 pockets that are 3/4 of an inch deep, you're taking 1/4 inch step downs. If depth first is turned on, it goes to the first pocket, goes 1/4 inch deep, 1/2 inch deep, 3/4 deep, goes to the next pocket, 1/4, 1/2, 3/4, goes to the next pocket, 1/4, 1/2, 3/4. If I uncheck that, it's going to go to the first pocket, go 1/4 inch deep, go to the second pocket, go 1/4 inch deep, go to the third pocket, go 1/4 inch deep, go to the first pocket, 1/2 inch, and so forth. The only advantage that I found of turning that off, and it's a huge advantage, is in situations where you have a pocket that's very deep compared to the wall thickness between 2 adjacent pockets. One of the first parts that I did with GibbsCAM had a bunch of lightning machining to do, to reduce weight. And they were the pockets were actually over 3 inches deep and had 1/8 inch radiuses in the corner. Had to do it with 1/4 inch end mill, 3 inches deep, and the wall between the pockets was only 80 thousandths. And when I did the first one, I did the pocket all the way down, no problem. I went to the adjacent pocket, when started machining it, it got about 1/2 inch deep and started vibrating like crazy. And so that's where I found this depth first checkbox. I unchecked it, and it sank all the pockets down together and left maximum stability, maximum support behind the wall as it was cutting. Other than that, I would always leave that turned on. Prefer subs is simply expressing a preference to the post processor that you would like it to generate subs for this toolpath, and then call up that sub at 340 deep, 680 deep, and so forth. Ramp down tells it to ramp from here, or from here, I think, to the first, to 340 on the first loop around, and then ramp from 340 to 680 on the next loop around, and so forth. And when it gets down to the bottom, it will make a full loop. When it finally reaches, the final depth, it'll go all the way around the contour at that depth to give you a flat floor. But the potential problem there is, let me go ahead and create a toolpath real quick. I'm not worried about the details here, but let me go to a front view, and what you see is it's actually doing it in 2 passes. I wanted to do it in 1. So I sometimes get a call that it's starting above the part and then it's ramping down going around, one time and then cutting it, and that's because ramp down is turned on. So it's starting at the top of the part, but it's going down this amount, or whatever, well, actually this amount, the actual Z step per time around, and then it makes a complete loop. So it's doing what we told it to do. So I'm careful to make sure that's unchecked unless I specifically want it checked. Delete this because I actually wasn't ready to create that. I just wanted to show you what that would look like. So we're going 340 deep. Retracts is off. That first subs is on. Ramp down is turned off, and back and forth is turned off. And I would probably never turn that on because you're alternating climb milling and conventional milling. But some people wanted this, so this would really, you know, some people might say that it's worthwhile if you're doing a single, like just this one arc right here, to go, you know, to go this way, step down, go this way, step down, go this way, step down. But I would climb mill, rapid back, climb mill, rapid back, climb mill, so that it's all, you know, I don't foresee me ever checking that checkbox, but it's there if you want it. All right, so hip flats we'll talk about in the roughing when we get to roughing on a solid model. This is how the tool gets from above the part to the first step down, from the first step down to the second step down. Auto plunge simply goes to the start point and feeds down at your entry feed rate. Plunge goes to whatever XY value you tell it to go to and plunges down and then feeds to the start point. So if I were to do this now, it would actually plunge at the center of this part and then feed out here. I never use plunge. I think I may have used it once or twice ever, and that was when I had an existing hole that was close to the start point, and I just wanted to make sure it was plunging at the center of that hole and not slightly offset. You know, the start point calculated a little bit off of that hole location. Ramp down I use sometimes if it's a fairly narrow shape that I'm cutting, and helix in I use almost all the time in roughing, but not in contouring. In contouring, typically I'm going to try to make sure that my tool is in open air when it comes down anyway. Either I've already roughed the part out or I'm starting off the shape. So typically on contouring it's going to be auto plunge. Round corners is simply better toolpath. It tells it if you've got a sharp corner to create that radius around the corner rather than straight line, straight line. So it's typically considered better toolpath. In addition to that, you can create a break if you want to. So
you don't have to draw them.
Right. If you've got sharp corners, you can say round corners, and then we're going to look at this when we get to another part tomorrow. Additionally, if this is a finishing pass especially, I could say give me a 5 or 6 thousandths radius on those corners, and it would actually save you having to deburr those vertical corners. I've got a customer that does a lot of electrical assembly boxes that have a bunch of little stand-ups, and they're typically square or rectangular, and they never model them with radiuses on the corners. And rather than going in and adding radiuses to them, they just do round corners and put I think they usually use 6 thousandths in here, and it just puts the 6 thousandths radius on the vertical corners. Cutter comp, this is just a choice of whether you want the post to output a G41 or a G42 to activate cutter comp. If you do this, you have to have a linear move as part of your entry that is equal to or greater than the amount you may need to compensate. So the operator at the machine, in this case, can compensate up to 100 thousandths because it's using 100 thousandths line. And then your coolant choices. So once we've done that, that's our roughing. I'm going to set up the finishing. We've talked about everything, so I'm just going to run through this real quickly. The only thing I'm going to change is going to finish size, and I'm taking that in one step. And then I'm going to select what I want to cut. Now, when I click on a piece of geometry, wherever I click, it puts my machining markers there. The machining markers are a tool that I can use to control contours. These will also be used on the lathe for almost all of your toolpath. So let me pause this for just a second. Okay, so since in GibbsCAM, I can zoom in on this all day long, they don't get any bigger. So I did a screen capture of the machining markers so that I could blow it up as a JPEG. So this is a close-up of the machining markers just so we can make sure that we're looking at the same portions of this. Now there are four different aspects of my toolpath that I can control with these markers. The first is which side of the geometry my tool is going to be on. And that's controlled by these larger circles Two of them will be yellow, and one of them will be this bluish white, whatever color that looks like to you. The one that's different, this one in this case, is the one that's selected. So with this selection, the tool is going to be on this side of the geometry. The second thing that I can control is which direction the tool is moving relative to the geometry, and that's controlled by the arrows. The blue arrow is the one that's selected. The black arrow is the one that's not selected. So the tool is going to be on this side of the geometry moving in that direction. Okay. The next thing that we can control is where the toolpath is going to begin. That's controlled by these two white markers, the little white circle, little white box. The arrow on the box has to be pointing to the first piece of geometry that's going to be part of the cut. The white circle will follow whatever piece of geometry the box is on, the white box is on, but it can be moved anywhere on that piece of geometry or off that piece of geometry, but it will just extend the piece of geometry that the box is on. The black markers, the black circle and black box, are the end markers. So the black box is the end feature marker, the black circle is the end point marker. The black box, the arrow in it has to be pointing to the last piece of geometry that will be part of the cut. The black circle will follow the box and then can be adjusted anywhere on or off of that piece of geometry, but it will just follow and then extend whatever piece of geometry the box is on. All right, so knowing that my markers are going to appear wherever I click, my strategy is to decide what's going to be the first piece of geometry that's part of this cut. And what I want to do initially is I want to drop down over in this area, swoop in and start cutting this circle here, and climb mill all the way around, recut this again and come off on this side. That way my tool is ending off the part. It's both starting and ending the cut off the part. So there should be no witness mark where my lead in, lead out is occurring. So I'm going to click on the first piece of geometry. That sets all my machining markers on there. That means that the white box does not have to be moved. It's already pointing to the first piece of geometry that's part of the cut. Now I do this in a very specific order. And I've gotten better with Gibbs since I first started. But one thing I noticed is, ironically, the thing that I'm most likely to miss when I'm clicking is these big circles. The biggest thing on here is the thing that I'm most likely to miss. And if you miss, you got to start over again. My screen's not updating. Again, the video is taking up my resources, so now it updated that time. But so I always select the side of the line first. Then I select the arrow because that's the thing that I'm most likely to miss next to the circles. And then I adjust my start point marker. I want to start over here. Notice it's just following that circle that the white box is on. If the white box were on a line, then the white circle would just extend the line. All right, so we're going to start here, that side of the line going in that direction. Those are already correct. I'm going to start out here. Now, if I want to set that to a specific number, a specific distance, I can right-click and go to move my start and end points, and I can say that I want my start point to be a ½ inch off of there, and I want my end point to be at a ½ inch off of there, and it'll move it automatically. Yeah, I just right-clicked on either one of these circles, either that one or this one. Now, also, if I want to machine only that circle and not go all the way around, see how the whole part turned dark blue? That means the whole part is part of this cut. But if I only want to cut just this one, I can right-click and say single feature cut, and it now only that circle is dark blue, so it would only cut that. I can also get there by double-clicking either one of these and toggle back and forth between machining the whole thing and just machining that one piece of geometry. This single feature cut only applies if you're starting and ending markers are on the same piece of geometry so you're on a closed shape. So this is the toolpath I want, like that. Okay. Now, if we want to watch this cut, go to an isometric view. I'm going to slow it down a little bit and watch this cut. Taking 3 step downs to get through. These chunks are coming off, I'm not concerned about that because we're just cutting pixels right now. Tomorrow we'll talk about roughing, and we'll learn how to rough this out instead of doing a contour. But this lesson is just in how to control a contouring process. That's all we're doing here. All right, so what I want you to do is create something like that, and then I just want you to spend a little bit of time experimenting with these. Say that I want to start here on that side of the line going in that direction, but maybe I've got clamps on this thing, so I'm going to move my start marker out here. So I'm going to cut the back side. I've got clamps on the front. I'm going to move my end feature here. Now I can do that either by dragging that box and pointing the arrow here. I can hold Shift and Control and click on that like that, or I can just let me move it here temporarily, or I can just right click on that and say, sorry, it's back behind this thing here. Move in feature here, and you see the shortcut is Control Shift Click. That's going to be weird in the video because on the video this little dialogue doesn't show up. So just remember, I haven't lost my mind. There's actually something that I'm moving around the screen. All right, so I want to end here or on this piece of geometry, but off over here. So I can say redo, and it does this. Now I've just scrapped this part, but I'm going to pretend that I don't know that yet. All right, so I've done this. Now I'm going to click on a blank tile, and I'm going to create toolpath starting here on that side of the line, going in that direction, starting off the part over here and ending over here. So now I've got one toolpath for the back of the part, one toolpath for the front of the part. What I could do is I could come into this one and select the last operation on that, right click, go to Operation Data, and insert a program stop. And I can lock that in so that even if I redo this operation, that program stop will stay. So the behavior now is going to be, it's going to run the back side of this, output an MOO, and you can actually have your post customized to do what you want here. I like for it to retract the spindle, center the table, and bring it out to me, and then re-output my offsets when it starts back up again, which it would do here anyway because it's changing tools. And then so it allows the operator to move the clamps, and then it machines the front side. However, I've scrapped the living daylights out of this thing, and let's watch why. So we're going to rewind, and we're going to play this. And the reason for that is that retract checkbox is unchecked, so it's not retracting between passes. So I need to come in here and open my roughing and select retract, open my finishing, even though I'm taking this in one pass, so this was not actually crashing, and retract it and hit redo, and then do the same thing here. That's why I mentioned that I tend to, my default position is to have that checked. If I've created toolpath and I find that my start endpoints are very close together, then I'll go back in and uncheck that. So it just, when I was, let me delete all this toolpath and recreate the first toolpath I had. Sorry, my mouse battery is dying, and it is just very, very sensitive. So let's say that we're doing this. Well, my start and end points are close together. There's nothing in between them. If I wanted to, instead of it retracting up and rapiding over, rapiding back down, and then feeding down, I could come in and turn the tracks off, and then it would just feed from this point to that point each time, if I so desired. Feed. Yeah. It'll. Matter of fact, I think it uses the entry feed across there. All right. What I'd like you to do is open this file up. We're about done for the day, but open this file up and just try some different things. They don't even have to make sense. We can cut this on the inside. I just want you to see what different ways of setting this, and once you've created toolpath, unless you're trying to do two steps like I did, front and back, hit redo just to overwrite that so you don't end up with 5,000 operations over here. And maybe say I want to go to over here. And always look and see what's dark blue. Make sure it's the part that you're actually wanting to cut. And just try some different toolpath, setting it up different ways. You know, start here on that side of the line, off the part out here, going in that direction, and end it over here. Just, you know, anything that strikes your fancy. I just want to make sure you can set these efficiently and get the results that you think you're going to get when you set them.